Thank you so much for Berkeley and the RDI group for putting this together. I'm Vincent. I'm one of the founding team members and a research leader at Snorkel. We've spent years building data sets with frontier labs and enterprises and deploying these agents in real-world scenarios. And in this talk, I wanted to talk about what makes benchmarks and evaluation methods really effective and how to actually make them last. How do you build really robust measurement sticks that are adopted by the field and actually influence the way the field is going? So really quickly about us, we've been working on data for a very long time. We have a number of academic groups, from Chris Ray's group at Stanford to Alex and Fred's groups at Wisconsin and Washington. And our key focus over the last decade plus has really been on data-centric methods for effective frontier AI. And so we're really privileged these days to be able to work with some of the best academic groups out there in accelerating and partnering on some of these open benchmarks. We're very humbled to work with some of these awesome benchmarks on the board. Very own kind of Don Song's Agents Last Exam. We were very happy to help as a data and research partner, helping with some of the quality control mechanisms. We've also partnered on a number of recent benchmarks, including Continual Learning Bench, also from Berkeley, out of the Skylab, OS World 2.0, and very recently the last few versions of Terminal Bench, which actually just shipped in the last few weeks. In this talk, I'm going to mention some of the learnings we've had on our work on these benchmarks and maybe put out a little bit of a call for the types of problems we think are going to be really important to solve in the space here. So the key problem here is that our ability to measure AI has really been outpaced by our ability to develop it. We're seeing that benchmarks in general are becoming really, really important, but they're also increasingly difficult to build. There are new challenges when it comes to take coding, right? Human eval launched several years ago is at 95%, and most recently the Harding programming benchmarks are at 3%. And as you climb the scale of complexity, you find that it's increasingly challenging to actually verify and evaluate a number of these tasks at the frontier. Benchmarks have also never mattered more. They are important for steering research agendas, model releases, and billions in compute are actually pushed towards hill climbing and addressing these benchmark gaps. We think that building benchmarks is a real research focus area that is non-trivial. Benchmaxing is a real problem. We think that models tuned to the test require a lot more thoughtful design and community contribution to ensure that we're providing really effective standards and measuring sticks for the field. What I'll call bench slop, the idea that you can really quickly vibe code a benchmark and get a fancy Twitter post out, is increasingly a really large problem where the individual task quality is lacking and a lot of effort needs to be put into designing extremely high quality tasks. And lastly, as model capabilities improve, they also improve at reward hacking and tricking and deceiving the benchmark builders, where it becomes a bit of a cat and mouse game in improving our methodology for building effective benchmarks. So this is really hard, and we want to talk a bit about some of our learnings for addressing these challenges and some examples that we've pursued. The other angle I wanted to talk through here was the fact that with agentic AI, the shape of data is becoming increasingly non-trivial. Right, we moved from a regime of much more simple prompt response pairs or simple thumbs up, thumbs down type of feedback mechanisms in terms of data labeling and data development to a much more complex stack of data sets and RL environments. Right now we're seeing entire environments or worlds built up, from rubrics to verifiers to tools with complex environments that mimic our day-to-day settings. And I'll note that this adds to the complexity in measuring these types of data sets. So as the surface area keeps expanding and certain tasks continue saturating, you might think, oh, we're done with certain fields, or we're done measuring coding, for instance. And I challenge that as you push the frontier along a number of axes of complexity here, right? One of our views is that sequence length, or kind of the length of autonomy on the y-axis, is a really important axis. And on the x-axis, we have kind of input, output, and environment complexity. Hey, what are the types of tasks or outputs that you're solving? It becomes increasingly more important to drive the next wave of benchmarks. And so, again, this is kind of what I alluded to earlier. There's a long tail and a very important space of problems to measure in the coding space, and Despite coding becoming so impressive in the last year or 2 years, we think there's a lot of work to do in the benchmarking space as well. Okay, so I want to talk about one of the benchmarks we recently pushed out and share a little bit of our philosophy interweaved in how we built this and what the principles are for building effective benchmarks. We launched last month something called Senior SWE-Bench. We were very fortunate to work with the original SWE-Bench team over at Princeton, and the key thesis for this benchmark was the fact that our agents are moving far beyond the level of junior engineering capabilities, but we don't really have a good way to evaluate them at the senior level. What do you think of when you think of a senior engineer? These are folks who can capture underspecified requirements. They can take an ambiguous problem and run with it. They have some notion of taste. We tried to address all of these types of issues in this next evolution of the SWE-Bench series. So a few principles first, right? We think that really effective benchmarks in general are one, kind of important research agendas for the space, and two, really well specified kind of measurement tools in general. And so, Senior SWE-Bench, as I mentioned, was the benchmark we're going to talk through here. So number one, the research agenda, right? We think that a lot of the greatest benchmarks have a really strong thesis on the frontier. They are making a bet on where the field is going. I think the Terminal Bench team did a wonderful job doing this, right? Several years ago, they made a bet to say, hey, we think that the future of agents is going to happen at the interface, the text-based interface that agents and LLMs are already doing a great job at. I think that was very much a correct bet, and we're seeing now that this is one of the most widely adopted benchmarks on, I think, literally every frontier model card. We think the best benchmarks also set a roadmap for the field. Again, SWE-Bench, released several years ago, has now seen a big series that we were very happy to contribute to the lineage of. And they're really great research tools for setting the stage for our fellow colleagues to build on top of. And really critically, we think the best benchmarks consider researcher UX. They really consider how do we make it easy for other folks to build on top of this? How do we build the right primitive so that other members of the community can actually contribute? So how does this apply to Senior SWE-Bench? What is our core thesis here? A few different points I wanted to make. Number one, we capture naturally underspecified instructions. So when you talk to a senior or principal engineer on Slack, you're not specifying a full EDD. You're not specifying, line-by-line instructions for what to do, what not to do. They're Slack messages. They're, hey, here's a dump of error logs. Go investigate this. Or, here's a few bullets on what I think the user stories are going to look like. Go figure this out. So that was one of the key axes we tried to capture, working with our expert network, but also a number of methods we built internally. Two, we captured a much longer horizon of tasks. So these are tasks that challenge engineering skills. They capture multi-service changes. They're not just a single patch in a very local way. They intentionally target really complex, longer horizon tasks. And three, we wanted to build this benchmark as something that could scale in terms of something that other researchers could build on top of. It wasn't a one-time effort. It was something that, hey, continually sources from the latest and greatest open source repos and helps us measure broader components of software engineering viability. And lastly, we wanted to capture this notion of taste, this idea that taste and maintainability is really important in modern, high-quality software engineering, and this was something that we saw was actually lacking in the current wave of benchmarks. So we introduced this notion of a tasteful solve, right? This idea that not only are we measuring correctness, but we're measuring notions of code-based alignment, practice alignment, bloat relative to an Oracle PR, a number of different metrics that you can look at on the actual blog post and website, but capture notions of quality beyond simply correctness. And so I'll shift now to the science, right? What actually makes a benchmark a really strong measuring tool? And a number of different kind of, this is like a greatest hits tour of some of my favorite benchmarks. And really quickly, task quality, really, really critical. GPQA was a benchmark several years ago that I was really impressed by. One of the appendix pages was one of my favorite contributions where they actually talked about how the pay incentives and the mechanisms of incentivizing contributors actually led to really, really high quality. Distributional control, defining a concrete taxonomy like an MMLU, which was very ambitious of its time in defining an academic taxonomy. Difficulty and headroom, right? Making sure that there's still room to run for these frontier models, and a really robust methodology for how you actually source and build tasks ends up being really, really important for effective benchmarks. And so I won't go into all the gory details here, but we ended up implementing a very rigorous quality control mechanism for this particular benchmark, right? Every single task relied on a suite of both agentic but also expert in the loop quality control methods to catch things like non-determinism, false positive and false negatives in the verifiers. And there were multiple experts, including myself and a bunch of our senior researchers at Snorkel, who would painstakingly look at every single task along with our expert networks, real software engineers in the field, to make sure that benchmarks like this were really, really reliable at the end of the day. So this is live. This was actually just updated last week. I promise you we triple-checked the results here, but remarkably there's a three-way tie for first place right now on the benchmark between Fable, Opus, and Sol, which is actually quite remarkable when you think about the Pareto efficiency curve. Again, this is on the metric of tasteful solves. So not only are these optimizing for correctness, they're optimizing for code-based practice and alignment to really senior engineering practices. So check it out. It's at seniorswebench.snorkel.ai. Just wanted to quickly call out some of our awesome collaborators. This was led by our co-founder Henry at Snorkel, along with the original SweBench team, Karthik's group, and Fred Sala, our chief scientist, and some folks at Wisconsin. And so the last thing I'll leave you with is we think that the future of benchmarks are going to need to capture a few really key axes of differentiation. Number one, we think we need to push the frontier of environment complexity. We need to push realism in terms of the types of workspaces and worlds that we're all operating in on a day-to-day, not just simple prompts and responses, but real code-based environments, scientific computing environments, legal workflows, or kind of real systems that people are working in on a day-to-day. Number two, we need to push the autonomy horizon for these models. We need to push how far these models can actually go when it comes to working autonomously and pull in humans in a bunch of these settings as well. And three, we want to push output complexity, not just in verifiable fields, but nuanced fields like legal and healthcare, where the definition of good is actually not a very simple, closed form solution like we've seen with mathematics, for instance. So I'll leave this with you, and the I guess final call to action is we're funding a number of these benchmarks. So if you're working on something exciting, if you'd like to collaborate, check out benchmarks.snorkel.ai. A number of the benchmarks that we put up there were in partnership with our Open Benchmarks grants, and I'm really excited to continue pushing and measuring the frontier with you all. Thanks so much.